Hello everyone, my name is Apurva Pancholi and we'll be continuing with the straight lines. In straight lines, we'll be starting with the new topic, which is point of intersection of two lines. Point of intersection of two lines. Okay, we know that equation of line can be represented as a1x plus b1y plus c is equals to 0, and equation of the second line can be represented at a2x plus b2y plus c2 is equals to 0. This was c1. Okay, now suppose these lines intersect at P. Suppose these two lines intersect at a point which is x1 y1, then this x1 y1 should satisfy each of these two equations. So I can write it as a1 x1 plus b1 y1 plus c1 equals to 0, and a2 x1 plus b2 y1 plus c2 is equals to 0. So solving these two by the cross multiplication method, we'll be getting x1 as x1 comma y1 as b1 c2 minus b2 c1 upon a1 b2 minus a2 b1 comma c1 a2 minus c2 a1 upon a1 b2 minus a2 b1. Okay, now we'll be doing some questions over it. So first question. Now find the coordinates of the point of intersection of these two lines. So line 1 is 2x minus y plus 3 equals to 0, and line 2 is x plus 2y minus 4 equals to 0. Now I have to find the coordinates of the point of intersection. So using the above formula, I'll be finding it as x upon 4 minus 6 is equals to y upon 3 plus 8 is equals to 1 upon 4 plus 1. Or directly I'll be getting it as x upon minus 2 is equals to y upon 11 is equals to 1 by 5, or x as minus 2 by 5 and y as 11 by 5. Okay. Now second question. This was simple cross multiplication method which we have already studied in 10th class. Okay, now I have to find the area of a triangle formed by the lines y is equals to x, y is equals to 2x, and y is equals to 3x plus 4. Y is equals to x, this is first equation, y is equals to 2x, this is second equation, and y is equals to 3x plus 4, this is third equation, let's suppose. Now solving the equation 1, 2, 3. Suppose these equation represents the sides AB, BC and CA of triangle ABC. Okay, so solving first two, that is solving 1 and 2, we'll be obtaining x is equals to 0 and simultaneously y equals to 0. This means AB and BC intersects at B 0, 0. Now similarly solving 2 and 3, we obtain x is equals to minus 4 and y is equals to minus 8. So this means that sides BC and CA intersects at C point, which is minus 4, minus 8. Similarly, solving for 3 and 1, we get x is equals to minus 2 and y is equals to minus 2. That is CA and AB intersects at A minus 2 comma minus 2. So as these are the vertices of triangle ABC, which is A minus 2 comma minus 2, B 0 comma 0 and C minus 4 comma minus 8, this gives the area of triangle as, we can find it by determinant method. So area is equals to half of minus 2 minus 2 1 0 0 1 minus 4 minus 8 1. Solving all this, we'll be getting as 4 square units. Okay, now we'll be moving towards the next topic, which is condition of concurrency of the three lines. Condition of concurrency of three lines. Okay, I'll be directly writing it as like, if line 1 represented as a1 x1 plus b1 y1 plus c1 equals to 0 and line 2 as a2 x plus b2 y plus c2 is equals to 0 and L3 as a3x plus by c3 is equals to 0, then directly we can say that if a1 b1 0, sorry c1, a2 b2 c2 and a3 b3 c3, as we know that it is in determinant form, by solving this, if we obtain 0 as a result, then we can say that this is the required condition of concurrency for three lines. Okay, now we'll be doing some questions over it. That is, first, now I have to prove that these lines, that is line 1 is represented as 3x plus y minus 14 equals to 0, line 2 as x minus 2y equals to 0, and line 3 as 3x minus 8 plus 4 equals to 0. Now I have to prove that these three lines are concurrent. How will I do it? By using the determinant form, as we have already seen. This is A, here coefficient is 1 and C1 is minus 14. Similarly, here A is 3, B here is minus 2 and C is 0. Similarly, here A is 3, B is minus 8 and C3 is 4. Okay, now putting in above equation, I'll be getting it as 3, 1, 3, 1 minus 2 minus 8 minus 14, 0, 4. So how will I solve it? Using determinant method. I'll be writing this 3. Now cross multiplication of this 4 into minus 2, minus of minus 8 into 0, then minus 1, 4, this by this into 1, minus 3 into 0, minus 14, this will be minus 8, minus of plus 3 into minus 2. By solving this, I'll be getting it, the result as 0, so I can say that these three lines are concurrent. Now similarly, question number 2. Now in this I have to find the value of lambda. Find the value of lambda when the lines 3x minus 4y minus 13 equals to 0, 8x minus 11y minus 33 equals to 0, 2x minus 3y plus lambda equals to 0, when these three lines are given concurrent. In the previous question we were finding the concurrency condition, and in this it is given that the three lines are already concurrent and we'll be finding out the value of lambda. So we will be knowing that A is this, A2 and this is A3. B1, B2, B3, C1, C2, C3. As these three lines are concurrent, determinant will be equals to 0. Solving it by 3 minus 11 lambda minus of minus 33 into minus 3 minus of 4 will become plus 4. This is 8 lambda minus of minus 11 into 2 minus 13. 8 into minus 3 minus of minus 11 into 2. By solving it, I'll be getting my equation as minus lambda minus 7 equals to 0. So lambda equals to minus 7. Okay, that's all for today. We'll be continuing next in the next lecture. Thank you.